Okay, it's just about time for the PSAT satellite pass to start. I heard the motor make a little noise indicating that it's starting to come up. So within the next couple of minutes, two things should happen. The arrow antenna here should start to lift up, and then also it should swing around. And this is south. There we go. So it's starting to move a little bit now. Um, so that's south, west, north. It should ultimately swing around to the north. Um, and just follow the satellite right by us over San Francisco. Um, on the laptop, I can actually see that the satellite's at 251 azimuth, 7 degrees elevation. So in the next few minutes, we should see this rotate around. It's got a margin set right now where as long as it's close enough to the antenna, it'll actually just park so that it doesn't oscillate back and forth, trying to hone in on the satellite. So any minute now, we should start seeing some more rotation, specifically rotation on this is called the azimuth, the left and the right, and then this is called the elevation, up and down. So there's a little bit of motion on the elevation. Um, The satellite's actually coming from like Hawaii, if I remember correctly. It's coming from Hawaii-ish, and it's going to come up over Santa Barbara and then head north up towards like Salt Lake City area. So we're going to see a really good amount of motion left to right because uh, it's a pretty big swing. The whole pass, the PSAT's pretty high altitude. It's actually higher than the space station. And if I remember correctly, the space stations are roughly 250 miles above the Earth, whereas the PSAT is about 350 miles above the Earth. So what that does is it gives us a little bit more minutes in our visibility as it goes across. So there's a little bit of motion right there. One of the new things that has been added to the R2D2M2 motor this generation is a little LCD screen on the back, which I'll take a picture of and show in just a minute, reporting the status of the Bosch compass accelerometer. This current mode right now is actually using the gyroscope, the accelerometer, to recognize left and right. The compass is turned on. It's listening to the compass made by OSEP, but it's not actually working with it. It knows what it's saying, but it's ignoring it. This is all pivoting right now off of the accelerometer, and the accelerometer is attached. This is the Bosch brand accelerometer attached to the top. So there's a little bit more motion left to right. These are Home Depot washers that just counterbalance the weight of the aero antenna. Even though the aero antenna weighs 1.5 pounds, because it's extended out so far, the actual weight back here is probably 5 pounds to counterbalance that. So right here we have a LCD screen. I'll do a close-up on that. Right here we have an Arduino. This Arduino is tasked with just listening to the Bosch accelerometer and also the OSEP compass, just out of curiosity, just to know what the compass reading is. The actual motor controller is actually coming off the ground right there. It's an Arduino motor controller, and it's turning motor 1 and motor 2. So motor 1 is left and right, motor 2 is up and down. These particular motors are faster. They're actually 35 RPM motors. I'm probably only using about 15 RPM at the moment, but they have encoders on them. So sometime this year, this fall, one of my projects will be to read the encoders and get the exact motion of the motors to work together with the Bosch accelerometer. The accelerometer appears to be very accurate, more accurate than the compass. So that's what we're using right now. So we can see we're getting some pretty good motion, tracking left to right. The angle right here is basically pointing to the PSAT over San Francisco, we're down in Orange County. It's really, really windy here. So there's probably a lot of microphone wind noise, but there's not a lot that can be done about that. But we're getting a pretty good pass. This is the black wire is the antenna wire, and the white wire is the it does two things. It's the motor controller wire, but it also sends the compass signals back down so that it knows the current position of the antenna to run against the math. So time-wise, we're past the halfway point of this pass, the PSAT. It's running from over the ocean, Hawaii-ish, San Francisco, and then it'll end up north in the north direction. So we have an event coming up Friday night at 8:15 or 8:18 this Friday. The space station will be visible. So hope to see you there, and we'll turn on the motor and have the motor track the space station on Friday. It knows how to track any of the NORAD objects. Also, it knows how to track the planet. So the other night we were looking at, there's a video you could see tracking Mars. But it'll track the space station, the PSAT, and the PCSat. Those are the primary things that it was intended to track. I've got the Angels baseball cap just to cover the electronics if it's in the sun for too long, just to not let things get too hot, because the iPhone doesn't want to get too hot in the sun, and neither do a lot of the electronics as well, so keep them shaded. But so far so good. It looks like things are working. We're getting good motion here, left to right, tracking the PSAT satellite. And when it's done, I'll take the camera and take some pictures of what's displaying on the LCD screen, so you can see the values that it reports. It's kind of nice to be able to look at it here and actually see what the antenna's pointing to, or what it thinks it's pointing to, and then compare that against what the computer is saying, because the computer reports two things. It's reporting where the satellite is, and it's also reporting where it thinks the antenna is, and the delta is the math that decides whether to turn left, right, or up or down. So far so good. This is the third version of the R2D2M2 antenna motor. The first version had left-right with a Z twist so that it would polarize with the space station. Realized that wasn't really necessary. The second version has one motor, just the left and right, and we hooked up the two elk antennas to that, so we had one elk on the right, one on the left. And this version basically takes the idea of the first one, but just sets the arrow antenna in the center, so it's pivoting in the center of the rack, whereas the very first version kind of had it a little bit asymmetrical. This is a more symmetrical frame, and seems to be working really fine. I think this is the actual first day ever testing it against a satellite, and it appears to be working perfectly. So far so good. The couple things over here. We have the battery. It's a 12-volt battery. It runs over on the board. I'll get a better picture of this, but it runs over on the board to two things: a down step to 5 volts, because the Arduino that runs the motor controller is a 5-volt Arduino Prima. Then also, the 12-volt goes to the motor controller because all the motors want 12 volts. So 12 volts also comes to the Arduino over here. So some things want 12 volts, some things want 5 volts. The Arduino has its own regulator to provide 5 volts to things like the LCD screen wants 5 volts, the compass and the accelerometer, they want 5 volts. But between 12 volts and 5 volts, we could pretty much run everything that we need to run right here. So far so good. Pass is almost done. We started back here towards the south. We just swung around to the west, and then we're going to end up kind of northeast in the northeast direction. But so far so good. One other thing that's going on is the radio is actually plugged in. It's under the little red bag to keep it out of the direct sunlight. It's actually sending and receiving packets, so later on tonight I'll be able to go online and see if any data was sent via the NASA website. So the website that we're tracking with is called pcsat.aprs.org or something like that. But anyway, if you go to our website, spacecommunicator.club, we have links to all the tracking information. There's two main websites that are used for tracking, one for the space station and one for the other satellites. The network itself is called ARISS, ARISS, Amateur Radio International Space Station. It requires an amateur radio license to use this particular channel, which is, this frequency is 145.825 megahertz on the 2-meter band. So it's a 2-meter arrow antenna. And we'll be able to go back and look at the historical record to see all the data that this is sending and all the data that this was receiving as well. One goal maybe for by the end of the year next year is to create one more LCD. I like the LCD screens because you can see them in the daylight, but to put one more LCD screen that actually shows the data that we're picking up from the satellites. It's really hard to look at a laptop and see in the sunlight to see what it's showing, but LCD screens are perfect for outdoor use. It's pretty windy out here, so it's probably picking up a lot of microphone wind noise right now as well. But we're getting pretty close to the end of the pass. Passes usually only last about 10 minutes. They're shorter when they're farther away and the lower on the horizon. This one was a pretty good one. It was I forget the actual transit, the highest point of the pass, but this one is lasting about 10 minutes. So this has turned out to be a really good practice. And so far so good. The motor seems to be working perfectly well. And we'll find out a little bit later how we did on the data. But at some point when the antenna gets to 0 degrees and like -1, we know that the satellite's already gone over the horizon, and the software knows to stop it at some point at 0 or -5. But it's nice to see it drop just a little bit below 0, just to be our visual indicator to know that the satellite pass has ended, and it's kind of a nice little visual reminder that our time's up. So we can't really control stopping and starting the pass of the satellite, so we just have to roll with it and go with the flow. But so far so good. This worked out really well. That's it. I think everything went really well this pass. I'm really happy. Sometimes things don't always come together, and sometimes they don't always work at the same time, but this one looked really good. Really happy with this one. Give it a thumbs up. Anyway, thanks for watching. It's a beautiful day. Friday night at 8:18, we're going to watch the International Space Station, our website, http spacecommunicator.club. We'll have all the information about when and where and our meeting this upcoming Friday. But thank you for watching, and that's it.